Hey, what's up everybody? TooTallToby here, and in today's Onshape step-by-step tutorial, we're going to take a look at some great sheet metal functionality in Onshape. And the data set that we're going to be working with is shown here. You can see this is actually rendering in Onshape Render Studio. So this is all taking place entirely in the browser, and look at how quick that preview updates, and I think it's so cool. You can even see the reflection of the springs there in the metal. So what this assembly is it's what's called a 90-degree locking hinge. And the way that this works is that you've got this component here, this kind of lever arm, and this lever arm has these little indentations that are sticking out and that are balancing on this round shape here. And so what happens is when you take this black handle and you push it down with your thumb, it causes this pin in the back here to lift up, to kind of ride up out of its groove. And once that pin has ridden up out of that groove, it's able to slide down this rounded shape here. And so what this mechanism is used for is when you're working in furniture and you've got two parts that are being held at 90 degrees, you're able to take one of those parts and collapse it down temporarily. So for example, if you designed a table and you have a leg on the table and you wanted that leg to be able to fold down, well, you could use a mechanism like this to do it. You could press down on this lever that would allow this spring to come up and then ride down this ledge here, and that would cause this whole side panel to flip down, and that panel of course is bolted to your leg of the table or whatever it is that you're trying to collapse down. And then when you're ready to flip it back up, you just do the reverse motion. You take that pin and you slide it back up that curved section, and then that pin is able to drop down into that groove, and that locks everything back in place. So this is a really cool mechanism, a really cool assembly here in Onshape, and there's a lot of neat sheet metal functionality in this assembly. And so I thought maybe what we could do is model up this part here, this part that has the slot in it where that pin rides up and down. And so if we switch to the window that contains that hinge part, we can see here that there's a lot of neat sheet metal functionality in this part. What we'll do with this model is we'll start out here by creating a sketch that kind of represents the overall shape of this thing. Now, of course, we're just going to model half of it and then we'll mirror it at the end. And so once we've got that sketch, we'll extrude that with sheet metal functionality like the wall thickness and the bend radius. And then what we can do is we can create this shape that's kind of sticking out the front. We do that using what's called a tab command in sheet metal. We're also going to get into the back area here. We're going to cut away some of these features in the back, and then we're going to create a sketch line here, and we're going to bend that sheet metal using that sketch line as the bend location. So it's pretty cool that you can do that in Onshape Sheet Metal. And then finally, we're going to introduce some newer functionality in Onshape. That is the forming tool functionality. So we're going to show how we can add these slotted embosses, which can add some strength to your sheet metal designs. When it's all done, we're going to finish up by mirroring the entire model, and we'll show you how you can actually show the flat pattern and export that flat pattern directly to DXF, directly from the Onshape model. So if that all sounds good to you, be sure to hit the like button and be sure to stick around, because what we're about to show you is a step-by-step tutorial on how to model this part in Onshape Sheet Metal. So this is a really fun project, and I wish I had enough time to go through all of the parts of this assembly. It's a lot of fun to build these parts, and it's a lot of fun to actually add the mates into the assembly as well. I don't think we're gonna have time to go through all of them. I think we're just gonna kind of focus on the hinge part, but I wanted to let you know that I am gonna store this part in the public repository in Onshape. So if you get stuck along the way in this tutorial, in this step-by-step tutorial, or if you just wanna take a look at the overall assembly and all the individual parts and maybe build the assembly or look at the assembly and its mates, I'm going to store this document, and I'm going to call it Toby 90-degree locking hinge. So anytime you're in Onshape, if you just search the public space, you can find this file, and then you could make a copy of it into your documents, and then you could actually poke through and make changes or look at my history tree, or do whatever you want with your copy of this assembly or of this document. So hopefully that will help you if you get stuck. And with that, let's get into the creation of this hinge part. So currently what we're looking at here is that lower part. This is the part where that pin would come up and it would kind of ride down the side here when we were looking at it in the assembly. Now we're going to make the mating part, the part that we're going to create is going to be the part that actually hinges open and closed at the 90 degrees. So if you created a new document for this tutorial, then you should already have a Part Studio down at the bottom. What I'm going to do is just add a new Part Studio, and then we should be able to follow along together. So I'm going to say create Part Studio, and this is probably what you've got down here at the bottom, this Part Studio 1. And so what I'm going to do is I'm going to just start out by renaming that Part Studio. Right click, rename, and I'm going to call this hinge part. And so now that I've got this hinge part in my Part Studio, I'm going to be able to now start creating some sheet metal geometry in this part. So let me just flip over so you can see my keyboard cam. And the first thing that I'm going to do here is I'm going to go to this flyout menu here, this hamburger menu up at the top, and just confirm that I'm working in the correct unit system. That way you can follow along right along with me in this new document. We're going to be doing this project in millimeters, so make sure that you are working in millimeters, and I'm going to hit the green check mark. And now we're going to begin our first sketch, and our first sketch is going to be here on the right plane. So I'm going to click on the right plane here, S key, begin a sketch, and then I'm going to press the letter N, and that gets me normal 2. And now what I'm going to do is I'm going to create kind of the profile sketch for this sheet metal extrusion. And so I'm going to start out by creating a line. So S key, line. I'm going to start at the origin, going to move over in this direction, single click, and then I'm going to move up in this direction and single click again. And now that I've created that geometry, I'm going to hit escape, and I think I'm going to make one more line here. So I'm going to create a line here that starts here at the origin and comes up, and I'll press the letter Q, and then I'm going to make this a vertical construction line. So you see, if you click on a line and you press Q, changes it back to solid, click on it again, press Q, changes it back to construction, or you could press Q while you're sketching it. Now, the reason I did this is because we're just going to model half of this part, but I know that the total width of this part is 38.75 millimeters. So when I press the S key and I go into dimension, I can create a dimension that goes from this line to the construction line, and I can cross over the construction line, and that lets me create a dimension here at 38.75 millimeters. So that's kind of a strategy that you can use if you know you're going to mirror the part at the end. You know you're just going to model half the part. You can use a construction line to generate your doubled dimensions. Pretty cool stuff, right? Normally you'd use this for a revolve, but we're going to use it for doubled dimensions. And then for the height of this thing, the height's going to come out at 29.2. And I know these dimensions might seem like they are very precise and very almost oddball. It's just because I took physical measurements off of a physical part, and this is what I came up with. So now that we've got those two dimensions, you got a horizontal line, a vertical line, 29.2 by 38.75. Now we're ready to turn this sketch into a sheet metal thin feature extrusion. And the way that we do that is we exit the sketch, and then we come up here to our Onshape menu for sheet metal. And the very first icon here is sheet metal model. Now, if you can't find this menu, you could always go up here into search tools. And when you go up here into search tools, you could choose sheet. And here we see sheet metal model. It's the first thing that comes up in the search. So we can choose sheet metal model there, and it's the same thing as clicking on the icon. And here in the sheet metal model, Onshape is telling us that we're going to be turning this sketch or some geometry into sheet metal. And there's 3 methods you could use: convert, thicken, or extrude. Well, we're going to use this third option here, extrude, and we'll talk about these other ones in some other tutorial. So we choose this option here for extrude, and for the thickness, we're going to type in a value of 2.5. And for the bend radius, this is going to be a little unusual. We're going to put in a bend radius of 0.2. And the reason I say that's unusual is because normally when I do sheet metal, the bend radius is equal to or greater than the wall thickness of the sheet metal. If you make the bend radius too tight, you risk either damaging the material or maybe even damaging the tooling that you're using to perform that bend. But in the case of these physical parts, the corners are almost sharp. They are unusually sharp. And so we're going to go with a very small bend radius here. Now, up in this top section, it says sketches or curves to extrude. We're going to click this line and this line. And now we see that Onshape is taking that geometry and immediately extruding it as a sheet metal feature, meaning it's extruding and it's already got the bend here. If you change this bend radius to something like 2 millimeters, you'll see that that bend gets larger, but we're going to set that to 0.2 millimeters to give us an almost sharp corner there where those bends are taking place. And so the final settings that you could examine here would be the depth of the extrusion. We're going to set the depth of that extrusion to 43.4 and enter. And the remaining settings, I think that they can just be left alone. For me, for my relief, my minimal gap here is 0.5 millimeters. My corner relief type is simple, and my bend relief type is tear. If your settings are different, you might get slightly different results than me in some of the corners, but for the most part, you should be able to follow along. Or if you just want to match my settings, that's fine. That'll make it easier to follow along with step by step. So once you've got these settings, the extrusion depth, the thickness, the bend radius, and then some of these settings down here under relief, the final thing to look at would just be that when you're doing an extrude of sheet metal like this, you've got this option down here to flip the direction of the sheet metal, and that allows you to have that sheet metal go to the outside or the inside. We're going to make sure that the sheet metal is going to the inside because the dimension that we took is the overall max dimension of this part. So this dimension here that we took, that's the overall max dimension of the part from outside to outside. So we're going to make sure that material is reflected appropriately in our preview. And since that all looks good, we're going to hit the green check mark. And there we go. That is the beginning of our sheet metal model. This truly is a sheet metal model in Onshape. You can go over here to this tab, and when you click on that tab, you'll see that the sheet metal menu flies out, and you can actually click on these faces and see the faces highlight over here on the model. So what this is showing you over here is the flat pattern of the model in its current state. Not really all that exciting, I know, but it'll get more exciting as the tutorial goes on. So I'm going to click on that tab again to kind of collapse that flat view. And the final thing I'm going to do here in this section of the video is I'm just going to rename these features. So this sketch here, I'm going to press Shift N. I'll call that sketch dash main L shape. Main L shape, and then sheet metal model here, I'll probably just call that the same thing. I'll call it SM dash main L shape. Okay, so that'll help me if I'm looking through the tree. It's always helpful to rename your features. The other thing that you can rename is the actual part down here, and the reason this is important is because this name is going to be reflected when we add this part to an assembly. So I'm going to press Shift N to rename that, and I'm going to call that hinge part -SM. A lot of times I'll append my files with SM just to kind of give me a visual indicator that the file is a sheet metal file. So if that all worked for you and you were able to see that thing in the flat pattern, be sure to hit the like button on this video, and we are going to move on to part 2 of the step-by-step tutorial. So in this next section of the tutorial, we're going to cut away some of the material from that original sheet metal shape. We're going to cut this kind of sidewall here. So we're going to add a little like curved section here, maybe a little radius on the back. And we're also going to cut this section in the back here so that we've got a tab. And ultimately, we're going to end up bending that tab in to give ourselves a little hinge point for the spring, a little attachment point for the spring. So let's create that geometry by starting a sketch here on this face. We pick this face, S key, begin a sketch, N key to get normal to. And for the first part of the shape, we're going to do a cutaway by just creating some geometry over here. We'll press the S key and begin the line command, and we'll create a line that starts up here in this upper corner and comes all the way down here to where the flat face touches the bent face. So all the way down there like so. Then we'll create a second line that kind of comes up here at an angle. And then for our third entity, we're going to move our mouse away from that endpoint. So we click once to drop an endpoint, move our mouse away, and then we're going to move back and then come off of that again, this time with a tangent arc. So that's a little trick you can do in Onshape. If you move over the end point of where two lines or where your new line is being sketched from, you can have Onshape transition from a line into a tangent arc. And so we're going to bring that tangent arc all the way up here to this upper edge, single click, and we're going to let go of our mouse and type in 15 as our radius, 15, enter. And then we're going to move our mouse back over this way and just kind of close off that region. Now we can hit escape, we can pick on this arc, and then pick on this line here, and we can press the letter T on our keyboard, and that adds a tangent relationship between those two entities. Pretty cool. And then finally, we'll press the letter S for our shortcut menu, and we will add a dimension here, and that dimension is going to be an angle dimension between these two lines here, and that angle is going to be 20 degrees. So that gives us the geometry for that kind of cut region on that side of this face, but we're not done with this sketch yet. If you need to, you can pause the video and you can take a look at this sketch and make sure that you've got it all locked down, all fully constrained, all black, the way that my sketch is here. But now we're going to move on and create a second section of this sketch, and that's going to be over here. So if we zoom in down here in this lower region, we're going to start out by creating a rectangle, and this will be a corner rectangle, and it's going to start here at this intersection of the bend and the planar face. So we'll single click there, move our mouse, single click again, and then what we're going to do is we're going to type in the dimension 7, enter, 3.75, enter. So that gives us a nice black rectangle, a nice fully constrained rectangle. We're also going to create a polygon just using lines. So you can press the S key, jump into the line command, and we're going to create a line here that comes over, and that's going to come over to a distance of 7 as well. It's going to come straight up here to a distance of 3. It's going to come up at an angle and then connect to the sidewall, and then it's going to close off. So you can create that geometry, hit escape, 7 over, 3 up, and then it kind of comes up at an angle. And then you can press the letter S and jump into dimension. And the angle that we're going to be going up at there is going to be an angle of 16 degrees. The gap between these two shapes, so the gap from here to here, is going to be 3 millimeters. And that should fully define that region of the sketch. So once you have all that geometry in place, you should be good to go. If you want to take a moment, maybe pause the video, make sure you've got that region good to go. And once you do, we're going to be able to move on here. So you've got this region fully constrained, this region fully constrained, and we're going to jump into an extrude command. Now, when you're working in solids, the extrude command will default to give you a solid extrude. But when you're working in sheet metal, anytime you click extrude, Onshape assumes that you're trying to cut into the sheet metal and not add material, because we would do that with different tools like adding a flange or adding a tab. There's different tools you use when you're adding solid material to a sheet metal. So what we're going to do is we're going to say we want this cut to go through basically one material thickness. So we could type in 2.5, for example, that's one material thickness, or we could say up to wall. We can do it however we'd like. But something that you might notice is that down here, we automatically cut away this entire lower region here, not just the rectangle, but we also cut away the bend because it really wouldn't make sense to just have the bend there. And I think that's pretty cool that Onshape is smart enough to recognize that. So we're going to hit the green check mark there, and boom, that takes care of those side cuts, those side wall cuts. So I think what I'll do is I'll go over here to the sketch and I'll do a Shift N to rename that. I'll call that sketch-sidewall cuts. And then I'll rename this feature here as well, Shift N cut, and then I'll just call it sidewall cuts. And I think that is looking good. If you were able to get to that point, good job, nice work. And if you do have any questions, be sure to let me know down below in the comments. But I think we're ready to move on to the next part of this tutorial. All right, so now that we've got that sidewall cut in place, let's add a little notch in the back here. There's a little tab on this part here in the back. So to accomplish this, what we're going to do is just pick this face here, S key, begin a new sketch, N key to get normal 2, and then what we're going to do is we're going to get in here and just create the sketch for that kind of notched shape. Now we're going to create this using line, so you can S key line to get into the line command, and then we can start here at the origin, move our mouse straight down like so, single click and let go of your mouse. You're going to type in 1 millimeter there, and then we're going to come over in this direction, and we'll use symmetry to define this dimension, so no dimension will get typed in there. Then we're going to move down in this direction and we're going to type in 3.7, and then we're going to move all the way over here to this little edge. If you need to zoom in a little bit, you can. We're going to pick this edge right here, kind of the inside edge, come up to this corner, and then close this sketch off. And so if we cut away that area, that'll leave us with that little notch there. The only dimension left is the width of that notch, and we're going to add in that dimension using some symmetry. So we're going to do S key line. We're going to single click here, move up, press the letter Q on your keyboard, Q, and then you can make a little vertical line there, and then we can add in a dimension there between those two, dimension from here to here, crossover. You see a crossover to get that doubled dimension, and that dimension value is going to be 12. And so there we go. Nice, easy feature for this one. Just a nice, easy cut here. And so for this one, what we can do is we can get that sketch. Let me go back to a normal view there so you can see those dimensions. So 12 for the width of that 1 and 3.7 for the depth there. That 3.7 is coming from it's 4.7 from the back, 3.7 off that one dimension. So now we can take that sketch and we can S key extrude. If you don't have extrude on your S key menu, you can right click and choose customize, S key extrude. And we're going to say that's going to be a remove, and we'll just make this one through all. So through all, remove, and boom. And so for the sketch over there, we can click on that sketch and Shift N. We can call that something like sketch, rear notch cut. And then for the feature here, so I'll click on the name of the sketch to unselect it. Then I'll click on the feature, Shift N. We'll call that something like cut, rear notch. Always good to rename your features. It's going to make it a lot easier for you to look at this tree later on and kind of quickly navigate through that tree. So I think that does it for that feature. Just one quick feature for this section of the video. Let's move on to the next feature. So now that we've got that rear notch in there, let's head back over to this section of the model and let's kind of continue modifying this side wall here. And what we're going to do is we're going to add a fillet up here in the corner, and then we're going to add the hole and the slot here to this side wall. So to add a fillet to a sheet metal model, you're not going to use the regular fillet command that you would use in a solid. Instead, we're going to use a sheet metal command called sheet metal break corner or corner break. So if we choose corner break here, you can see that we can indicate that we want to create a fillet or a chamfer. We're going to create a fillet, and we can indicate the entities to be radiused. Well, the nice thing about the sheet metal break corner option is that we don't have to zoom all the way in here and pick this edge. You can just pick a vertex, and that makes it a lot easier to make your selections when you're working in sheet metal. You don't have to zoom in and get that exact edge. You can just click this vertex here, and there you can see that that whole edge gets filleted off. So what we're going to do is we're going to add in a fillet there. We're just going to put in a radius there of 10 millimeters, enter, and enter. And oh yeah, that takes care of that corner. And that is our corner break. We could rename this. If I do Shift N, we could call this something like rear upper corner 10 millimeter, something like that. Rear upper corner 10 millimeter makes it very clear what's going on with that feature. And now we're going to add in the sketch for the slot and for the hole here. So we're going to pick on this face again. So maybe press the space bar to clear your selections. You notice there that I had that face selected, and then I also picked this face. So the cursor says 2. It's indicating I've got 2 things selected. So we press the space bar, that clears our selections. And now we can pick this face, S key, begin a sketch, N key to get normal to, S key, we can drop in a circle here, and that circle is going to have a diameter of 5.1. That's going to be the hole for the rivet to fit through, so this thing can hinge. And then we're going to do S key, and we're going to create a line, and this line is going to have a length here of 13.5. And once we create that line there with the length of 13.5, we can hit escape and we can go up here to the offset menu. And if you expand the offset menu, you'll see that slot is listed underneath there. And this is how we can create a sketch slot. So we're going to go in here to the slot option, and then we're going to click on this line. And then what happens is Onshape says, well, what do you want the diameter of that slot to be? And so what we want is we want that diameter to be 5 millimeters. So we can double click there, type in 5, enter, and there we go. We're done with that slot shape. So that's a real good one to practice, especially in sheet metal. It's good to know how to create these slots. We see these a lot in the world of sheet metal. So really good to learn how to practice that and get that tool in place so that you can quickly create that geometry. So now we're just going to add a couple more dimensions to this thing, and we can dimension these right from these planes here on the back side of the model. So S key dimension, the dimension from the floor or from the top plane to this center point here of the slot is going to be a distance of 15.5. The dimension from that same top plane up to this hole here, the center of this hole, is going to be 20.4. The dimension from this plane over here, from the kind of right plane over to this point, is going to be a distance of 9 millimeters, so 9 millimeters to the center there. Again, from this plane here over to the beginning of our slot is going to be a distance of 18.5. So kind of cool that you can use the reference geometry from the model, the front plane, the top plane, the right plane, especially when you're working in a sketch and you don't really have a clean edge that you could pick from. This really makes it nice, and it makes it easy for you to get the geometry and to define the geometry in a way that it's not really going to be susceptible to changes. So that's a pretty nice way of creating that sketch. And now that we've got those side holes, or the side hole and slot in place here, once that sketch looks good and it's fully constrained, you can use the S key, extrude. And remember, we're in sheet metal, so the default extrude type is going to be remove. And we're going to say through all, and then we can hit the green check mark, and there we go. We've added that geometry for the side hole and slot, and so we could rename that appropriately. So here for the sketch, we could say Shift N, and we could call this something like sketch, side hole, and slot. And then for the feature here, so click on the sketch again to unselect it, click on the feature, Shift N, we could call that something like cut, side hole, and slot. And that takes care of that feature. We are moving along nicely with this design, with this step-by-step tutorial. I hope that you're enjoying this so far. If you are, be sure to hit the like button. Let me know down in the comments what you're enjoying about this tutorial. And of course, if you have any questions, let me know that as well. And we are going to move on to the next step. So now that we've got those side holes in that side wall, the hole and the slot in that side wall, now we're ready to move on and add this geometry here where we're going to create a line, and then we're going to use that line to bend this tab over. Now, you might be asking yourself, you know, if our goal is just to create a tab here that's kind of bent off at an angle, why not just pick an edge of the model and do a traditional sheet metal flange? So here you can see I can create a flange, and I could create that flange maybe at an angle, 45-degree angle, and there we go. We've got our flange at an angle. Why not just do that back here along this edge back here? And the answer to that question can be found by inspecting the flat pattern of the sheet metal part. So if we choose the flat pattern command over here, the tab over here, to look at this thing in the flat view, what we can see is that the way this thing was designed was such that it could be punched, and this back wall of the part will be perfectly in line with this edge here of the flange that we're about to bend, of the geometry that we're about to bend. And this will happen a lot when you're working in sheet metal. It might make sense to kind of have different elements aligned in the blank and then bend them afterwards. Well, if we were just to pick an edge of the model here and then create a flange that's sticking off here at an angle, it'd be very difficult to get that length to be perfectly in line, especially in the flat. It'd be very difficult to figure out the math to figure out what that needed to be. But it's very easy to do here, you know, once we've essentially got the flat and then we just want to add a bend. And that's going to happen a lot in sheet metal. So this is a really valuable skill to know how to do that bend while the model is essentially in a flattened state. And it's really simple. All we need to do is just pick this face here and then begin a new sketch. So pick that face, begin a new sketch, and we're just going to sketch a line here that goes vertical from this edge down to this edge. And that's it. It's just that simple. All we need to do after that is just add in a dimension as to where that bend is supposed to take place. And in this case, we will add that dimension from this edge over here to that line, and that dimension will be 1.5. And if you sketch that line and that line was vertical, then you should be left with a nice fully defined, fully constrained sketch here, and that's going to become the location of our bend. So once you've got that line in there, offset at 1.5, you can exit that sketch. And then you can come up here to your sheet metal tools. And from your sheet metal tools, you can choose the command bend. So sheet metal bend. And in the bend command here, you can see you've got this option for a bend line. So this will be our bend line here. And look at that. As soon as you click that bend line, Onshape is smart enough to just automatically add in that bend. So we're going to say that we want to reverse the angle of that bend. So we choose opposite angle, and the preview updates here. And then we've got some additional options here, like where is the bend taking place? So you've got this option here for hold line, which means that wherever we sketch the line, that's where the bend is going to take place. You notice the flange got a little bit shorter there. You've got the option for bend line, which basically means that where we sketched our line is kind of the middle of the bend. So that's actually going to be the option that we use. There's also some other options here like inner and outer And that has to do with where the material is relative to that line. So inner works, we can have the material aligned inner to where that line was, but we can't do outer because there's not enough room for the outer. We don't have 2.5 millimeters worth of meat here. We only have 1.5 here coming to that line. So there's not enough room for that material to exist on the outside or with the outside of the material aligned to that line. But we're going to use the first option there, bend line. And then for our angle, we're going to set our angle here to 60. And that should give us a nice little tab sticking off there. And that will be the tab where we will hook the spring onto when we get to the assembly. I know we're not going to do the assembly here in this video, but like I mentioned at the intro to the video, if you just search the public space for this file name, Toby 90-degree locking hinge, you'll find the public version. And then you can take a look at my assembly and you can see how I made that spring into place. So we're going to hit the green check mark there, and then we can just rename these features, rename the sketch, and rename that feature. This sketch here will be called Shift N. We'll call that sketch location of, we'll call this one spring hook bend. And then we'll call this one here bend. We'll call this one spring hook bend. I think it's a pretty nice name for that one. And that should take care of those features. And now you have a little bit more experience working with the sketch bend in sheet metal. And so the next thing that we're going to do is we're going to add some material up here, up in the front of this part. We're going to add a little kind of like a T section up in the front of the part. We're going to do that using what's called a sheet metal tab, but we'll do that in the next section. So I mentioned a little earlier that anytime you go into the extrude command, when you're working in sheet metal, you're going to end up with a cut or a remove in the extrude command by default. And that's because we don't add material to sheet metal models using the extrude command. We add material using commands like the flange command, like I can click on this end here and I can do a flange. Or we add material using what's called the tab command, and that's what we're going to do in this step. So what we're going to do is click on this face here, S key, begin a sketch, N key, and then we're going to create a sketch here of this kind of front T section of this model. So you can begin a line command, so S key line. You can pick on this corner here, and we're going to come out a little bit, and then we are going to come over here to this side, come down like so. We're going to come back in like so. We're going to come back over to here, and then we're going to close off that sketch. And then we're going to create another line here, and we're going to press the letter Q, and that'll allow us to establish symmetry for some of these dimensions. So we'll make that line horizontal, and now we've got a nice construction line that we can create doubled dimensions to. So for the dimensions, S key dimension, we'll pick this outermost line here. We'll pick that construction line, cross over that construction line, and we'll type in 49.6. That's our max width there for that section. We will pick this kind of intersection here, come back to that center line, cross over to get that doubled dimension. That one's going to be 33 millimeters. And then we are going to add in a dimension here, the thickness up here at the front part of the T, 12. And then a final dimension, and this dimension is going to come from this location here, not from the origin, but from the backmost tab that we kind of notched out all the way up here to the front of the sheet metal part, and that distance is going to be 60.6. So not to the origin, but to that kind of notched area that we cut in an earlier step, 60.6 to the very front of the model. And we can see here that the remaining dimensions, 49.6, the max width, 33, that width in that like slightly more narrow section, and 12 millimeters here for that front T section. So once you've got that geometry, once you've got that sketch and that sketch is fully defined or fully constrained, we're going to add material to the sheet metal part. And the way that we do that is we exit the sketch. And then instead of choosing extrude, that's what you would normally do with a solid. Instead, we're going to fly out the sheet metal menu and we're going to choose the command tab. So when we choose the command tab here, then what we can do is we can click on this region, and Onshape automatically looks at the sheet metal model and just automatically extrudes that geometry from that sketch down to match up with the existing sheet metal thickness. So you'll notice here when I hit the green check mark, boom, it just merges everything together and leaves us with this nice sheet metal result. And that's what's known as the tab command in sheet metal. And so for our sketches over here, we'll rename this sketch Shift N. We'll call this sketch front T section. And then for this tab here, we can rename this feature here Shift N tab dash front T section. And that does it for that feature. Nice, easy feature there, but a good opportunity for us to show how we add material in sheet metal. We don't do it using the extrude command. We do it using the tab command. So this next section of the video is not really all that exciting. It's just kind of one of those things you have to do when you're working in sheet metal, and that is create a sketch for a bunch of holes. So we're going to do that here on the topmost surface. So we pick this topmost surface here, S key, begin a sketch, N key to get normal to, and we're going to get in here and we're going to start adding in these holes. Now, sometimes if you change the view a little bit, if you press the N key again, you'll get normal to in kind of a slightly different direction. That can sometimes be helpful to know because you can see here if I go to sketch this line is horizontal. If I rotate the view a bit and I press the N key and then I go to sketch a line again in this direction, you can see now this line is horizontal, or this line going in this direction is vertical. And that can be a little bit disorienting. So instead, what I'll do is I'll just kind of rotate the view a little bit closer to this orientation and I'll press N. Or the other thing that you can do is you could press Shift 5. Shift 5 is going to be a top view, and it doesn't really matter what your orientation is. Shift 5 will always take you to a top view where horizontal is horizontal. So at least if you're sketching on the top plane. So if that works a little better for you, you can use Shift 5 as well. Anyhow, let's get in here and create the geometry for these holes. So S key, circle, and this circle here is going to be located right here along this middle edge here, and that circle is going to have a diameter of 4.4, and then we're going to create a bunch more circles that are all going to have that same diameter. So we'll create one there, we'll create one there, we'll create one kind of up here, and we will create one up here on that T section. And then we can hit escape, and then we can pick all those circles. So 1, 2, 3, 4, 5 circles, and we can press the letter E, and what E does is it makes all those circles equal. Now for the location of this one here, we might want to create that construction line so we can get the doubled dimension. So S key line, single click here at the origin, move up, press Q, move kind of over in this direction, and there we go. We can hit escape, and then we can do S key dimension, and dimension from this point to that construction line, and then kind of cross over that construction line and drop in that dimension, and that dimension is going to be 14 across the center, or 14 center to center once we mirror this thing. And we'll do the same thing with this point out here. We'll pick this point, pick that construction line, move across here, and this one is going to be 37 center to center across that construction line, or across the middle of our part once we mirror it. So 14, 37, and now for our dimensions to the location of these holes, we're going to take these dimensions from the very back of the part. So in other words, from this plane here. So we're going to create a dimension that goes from this plane to this location of the first hole there, 8.1. We're going to go from this plane to the location of the second hole here, the one that's kind of floating out there. That one's going to be at 10.6. From this plane out here to this third one here, that one's going to be at 31.5. From this plane out here to this fourth one, that one is going to be at a distance of 48. And then finally, this one out here, we're going to define that one relative to the front edge of the part. It's not quite in the middle. It's a little bit favoring the front. So we'll put that at 5.7. So I'll just move this into place here so you can see these dimensions. So here we go. And we're going to add one more hole to this sketch. So if you need to, maybe take the end point of this construction line and move it a little further over here so it's not in the way. We'll get this guy back over here. And whoops, and we'll put this over here, 14. So there you go. If you want to pause the video and make sure that you've got all those dimensions correct, all those holes are 4.4. And now we're going to add one final circle here. And this circle is going to be somewhere in this region right here. And this circle has a larger diameter of 8 millimeters. And then the distance to that hole, so S key dimension, from the back plane of the part to that hole, that distance is going to be 19 millimeters. And so that is your sketch of those holes. Like I said, it's not the most exciting section of the video, but sometimes it's important to learn how to do this, or at least just to do it when you're working with sheet metal parts. So if you enjoy punching holes in sheet metal parts, be sure to hit the like button. Be sure to let me know down in the comments. And I'm going to now S key and extrude. And by default, because we're in sheet metal, this is going to be a remove. And I'm going to make this through all. And there we go. We hit the green check mark. And look at that. That thing is looking good. And so here for our sketch, we could call this one sketch dash bottom holes. And then this extrude here, we could call this cut dash bottom holes. And that will make it much easier to understand what we're looking at when we come back and look at this project 6 months from now and can't remember anything that we did with this project. And so we are kind of coming down the home stretch. The next thing that we're going to do is we're going to add in a little bit of a strengthening feature here. We're going to add in an embossment, a slotted embossment here, and that's going to add some strength to this sheet metal model. So when we're working in Onshape and we're working with sheet metal, we've got the ability to access what are called form tools. It's over here in your sheet metal toolbar. It's called form. But before we start dropping in these form tools onto our sheet metal parts, we want to make sure that we have the location locked down for that form tool. So we're going to start out here by clicking on this face on the top of the model, and then S key, begin a sketch, N key to get normal 2, and then we're just going to drop in a point here. So we can just drop in a point like this, and there are going to be 2 of these embosses, so we're going to use the symmetry option, so we can create a line here, Q, kind of drop in that line like so, and then we can S key and create a dimension here that goes from this point to that line and crosses over that line. And so the distance between these is going to be 18.2 millimeters, and then the distance from the front of the model back to this point is going to be 20 millimeters. So 20, 18.2, and that's it for that sketch. 18.2 across the center and 20 for the location of that form. So now we can exit that sketch. So now we've got a point here just kind of sitting here on that top surface. And now we're going to go into our sheet metal tools and we're going to choose form. And this is where we can access our library of forming tools in Onshape. So we choose form, and here where it says locations, we're going to click on this point. And now at this point, you may see a preview, you might not see anything. You probably haven't set up your library yet. So what we're going to do is we're going to come up here to where on my screen it says circle emboss. We're going to click on that, and then that's going to take us into our ability to choose a library. So you've got this first tab here that says current document. You've got this tab here that says other documents, and then you've got your libraries. And what you should take away from this section is that you've got the ability to create your own forming tools and use those forming tools in Onshape. But what we're going to do is we're going to work from the existing library of Onshape forming tools, and that library comes here from this third tab, libraries, and then here in this flyout menu we're going to say Onshape Sheet Metal Forms. From the second menu here, we're going to say Onshape Form Library. And then from this third menu here, we're going to choose this option of Slot Emboss. So you can use your scroll wheel here and scroll down through that library. And we're going to choose Slot Emboss. And then you notice that the preview goes red. This is much too large for this geometry. So we're going to set this to use a length here of 20 millimeters. We're going to choose the length is going to be measured to the slot centers. For the width here, we're going to set that to 3.5 millimeters. And for the height, we're going to set that to 1 millimeter. The angle here is going to be 90. And then the radius control, we're going to make that half thickness. And so if you click this button now that says generate preview, hopefully it works for you and you're able to see a preview of what that emboss looks like. If it's going the wrong way, like if you made your sketch here on this bottom surface, then you can click this button that says flip direction, and then that'll put that on that upper surface. And that is how you can create a form tool here in Onshape. If you choose done, and then click the green check mark, you'll see that that form tool is now going through your model, and look at that thing. That is looking good. And that is how we could add some strength to this sheet metal model. So we are really truly coming down the home stretch here. We could come over to the tree. We could rename this. This sketch could be Shift N, and that could be sketch for form tool location. And then for the form tool, you could maybe call this something like Shift N form slotted emboss. Something like that. But yeah, we are really coming down the home stretch here on this model. Just a couple of more cleanup features. We're going to maybe add some more fillets, like how we added this fillet up here. And then we're going to mirror this thing, maybe apply an appearance and a material, and we are pretty much done with this thing. So one of the things we talked about earlier is that when you're working in sheet metal, you typically use some different tools than when you're working in solids. And one of those tools is the fillet command. When you're working in a solid, you'll use the fillet command, but in sheet metal, you'll use the command corner break. So we're going to use this command now to kind of clean up some of this geometry, and we're going to apply a 3mm fillet on this edge and on this edge. The nice thing is that because we're working in sheet metal, we don't have to zoom all the way in and pick that edge. You can just pick the vertex that is related to that edge, and Onshape is smart enough to figure out what the appropriate edge is for that fillet. So we're going to come around here to the back side, and we're also going to add a 3mm fillet here on this corner. So this corner here that's kind of wrapping down and around. And finally on this corner here, kind of like the backside corner of the model, just kind of smooth that out a little bit. And once we get those 4 corners selected, we can hit the green check mark, and that adds those corner breaks. And then we'll do the same thing, but this time with a 1mm fillet. So we'll again go over here to sheet metal corner break. This time we're going to choose to add a 1mm fillet, and the 1mm fillet is going to be applied here. So you see it gets that little corner there, right there in that little region. And then on the back side, we're going to add it to 5 corners. So those 5 corners are going to be 1, 2, 3, and then these 2 front corners here, 4, 5. So very easy to pick those. You don't have to rotate the model. You don't have to pick the edges or anything. Just pick those 1, 2, 3, 4, 5, and then this other one that's up front here. So once we get those 6, we can hit the green check mark, and that adds those fillets, and we could maybe rename those. Over here, you could call it something like break fillet 3mm, and then maybe like break fillet 1mm, something like that. Fillet 1mm. You could also call them smaller and larger. Sometimes I avoid actually putting in the value since it's not dynamically linked. You might change the fillet but forget to change the feature tree, and that could be confusing for somebody later on. So sometimes I'll just name them based on where they're located, but in this case we're using a pretty standard fillet of 3 and 1 for the whole project, so I don't think it's going to change. And so now we can take all that geometry and we can perform what's called a mirror all, or a mirror here in Onshape. So we click the mirror command, and up at the top of the mirror command, you've got the option for part mirror. That's what we want. So the entities to mirror, you just click anywhere. And then here where it says mirror plane, we're going to choose over here on this face of the model. And then you just need to remember when you're doing sheet metal to do an add here. If you look down in your parts list, you'll notice that currently the mirror is set to new, and so the parts list is actually generating a new part here. So you're gonna have like a part 1, part 2 on each. You have like a mirrored half of the model. That's not what we want, so we're gonna make sure that we choose add. So you click that button that says add, and now we see that down here in the parts list we just have the one single part. This is gonna get merged together, and that is what we want from that model. So I think that pretty much does it as far as the geometry of this model. There are going to be some additional things you're going to want to do for cleanup. So for example, what we could do here is we could press P on our keyboard, and what P does is it takes that geometry and it hides the reference planes. You could also press Shift P, that hides everything else. So that'll hide all the sketches, it hides the origin, just kind of makes the model look a little bit nicer on screen. We can also come over here to the name of the part in the parts list. We can right mouse button and we can say assign material, and maybe we'll just assign like a steel material to this, like a 300 series stainless. That should give us a close enough density to kind of get close to the mass if we were to measure the mass of this part. And then we could also come over here and we could right click on the name of this part, and we could go to edit appearance. And when we go to edit appearance here, we can see that we can change this to kind of a gray color to match up with the actual color of the physical part. So that takes care of all the appearance things for this. And I think that the final thing that I would want to do would be just to inspect the flat pattern of this. So we come over here to where we can choose the flat pattern view. And when we inspect the flat pattern, we can see that we get a bend table up top here indicating all the bends that are a part of this. So there's really only 4 bends that are a part of this model. And then we also get a flat pattern down here. And look at that flat pattern. That looks pretty cool. I like being able to see this thing in the flat pattern. And I like how in Onshape Onshape, if you click on a face in the flat pattern, it highlights that face up here in the graphics area, in the formed area. So it really helps you to inspect your models and make sure that everything looks good before you send it over to the machine to get cut. But now at this point, what we can do is we can right click over here in this flat pattern. And from the right click, we can choose export DXF DWG of flat pattern. So right from Onshape, right from this flat pattern view, you can go right out to a DWG or right out to a DXF. And you can see here that you can control what the name of that part is going to be. You can control some options for the format, and you can control where it's going to land. So you can see here you have this option download, and store file in a new tab, or store file in a new tab. So I'm going to choose that option, store file in a new tab, and then I'm going to choose export. And so what happens is we get a new tab down here, and we can just click on this tab, and right away we can inspect what that flat pattern DXF actually looks like. So here you can see what that flat pattern DXF looks like. So this gives you one final chance to inspect this thing, and then if this all looks good, you could go back to the part here, you could right click, you could say export DXF DWG, and this time you could choose the option for download. And then once you download that, you choose export. That's going to download it to your computer, and that way you'll be able to send it over to your plasma cutter, your water jet, or whatever it is that you're using to cut your sheet metal blanks. So that does it for the sheet metal tutorial for this part. I hope that you guys enjoyed that tutorial, and I hope that you learned a lot. We got to cover a lot of cool sheet metal functionality. We started out by doing that extrude with our sketches of our thin lines. We got to add in a sketch bend on the back here. We got to use a forming tool. We got to use tab. We got to show how to do cuts when we're working in sheet metal. So we got to show a lot of good functionality in sheet metal, and even some bonus functionality when it comes to working with symmetry. Let me know down below in the comments if you learned anything cool or useful from this tutorial. Let me know if you have any questions. And I know I've said it a couple of times, but if you want to, you can take a look at this entire project, including the assembly, by doing a search here in the public space for this syntax, Toby 90-degree locking hinge. And that way, if you got stuck during this tutorial, you can actually take a copy of this part and look through the entire tree. Or if you're interested in seeing how I constructed some of the other parts, you can take a look at them as well, and even take a look at the assembly of this 90-degree locking hinge. Be sure to hit the like button on this video before you leave. Be sure to subscribe to the channel, and of course, be sure to come back for the next Onshape step-by-step tutorial.